Hey guys, today's lesson is going to be on graphing quadratic functions. So we're going to start off with some guided notes. So first thing, the graph of a quadratic function. The graph is called a parabola. So let's write that down. And the parabola generally looks like something like this. Write this down, like a U shape. Or like this, an N shape, not a V. So these are curves right here, not straight lines, it's curved. So that graph is called a parabola, and there are three different forms of quadratic equations, and you can see the three different forms down below. The first one we're going to talk about is standard form. So this is standard form. And that's that ax squared plus bx plus c. And if you think about it, you have seen, when we were talking about factoring trinomials, we factored trinomials that were in the form ax squared plus bx plus c. The next form that you see, the one right there in the middle, that is called vertex form. And the final form, the one on the end, is called factored form. So you have x plus or minus a number times x plus or minus another number, which we have dealt with in the last unit on polynomials when we were factoring trinomials. So some things to know about when we are graphing these quadratic functions. So that a, wherever that a is really important. So if a is negative, then the graph opens down. And it's got that N shape, that lowercase n, like that. If A is positive, then the graph opens, up. We have that U-shaped graph. I'll put an arrow there. Okay. All quadratic equations have a blank, which is the turning point of the graph. So that's the vertex. They have a vertex. That's referred to as the turning point. You might think of it as a maximum point or a minimum point, depending on how the parabola is opening up. Quadratic graphs are symmetrical across the blank, which runs through the blank. So they're symmetrical across the axis of symmetry, and we'll talk about that in a minute. And that runs through the vertex. So the axis of symmetry is just a vertical line that goes through the vertex. And it's symmetrical, meaning if we folded our parabola along that vertical line, it would be congruent. You'd see two congruent figures. So the formula for your axis of symmetry, remember I told you it's a vertical line. Vertical lines are always of the form x equals a number. So to get that number, you're going to do negative b over 2a. So if you look back at the formula in standard form, so if you know the b value and the a value, that when the equation is written in standard form, you can find the equation for the axis of symmetry. Okay? A quadratic function crosses the y-axis at the y. That's going to be at the y-intercept. Okay? Scratch that. Not at the y-intercept. We're going to say it crosses the y-axis one time. It's always going to cross the y-axis exactly one time. Okay? The y-intercept, remember that's the point where the line crosses the y-axis, always has an x value of blank. Well, anytime you're talking about a y-intercept, your y-intercept has an x value of 0 because the y-intercept is the point on the y-axis. For a parabola, the y-intercept is always going to be the point 0, C. So if the equation is written in standard form, we can see that really easily. So because when you plug a 0 in for x, these guys are going to cancel, leaving you with just c. So 0c. Now a quadratic function can cross or it can touch the x-axis. It can not touch the x-axis, so 0 times, or it can touch it just 1 time, or the most would be 2 times. So a quadratic function can cross or touch the x-axis 0, 1, or 2 times. Okay, so let's look at this graph. So this is the graph of a parabola. It is a quadratic function. So let's start off by identifying the vertex. Okay, so my vertex is going to be right here. So that ordered pair is 1, and that is 1, 2, 3, 4.5. Okay, the axis of symmetry is the vertical line that goes through the vertex. So this line, I'm drawing a dotted line right here. And I'm going to put little arrows here. That is the axis of symmetry. So that is x equals 1. The y-intercept here is going to be right here. So that's 0, 1, 2, 3.5. The x-intercepts. So an x-intercept is a point where the graph crosses the x-axis. And this parabola crosses the x-axis 2 times. So we see it crossing the x-axis here and here. Okay, so the x-intercepts we see are negative, let's call that negative 1.25, comma 0, and 1, 2, 3.25, comma 0. Okay, so those are the ordered pairs for the x-intercepts. All right, let's go to the next page. So let's suppose you need to graph a quadratic equation that's written in standard form. So that's that ax squared plus bx plus c. So let's take this example. We've got f of x is equal to 4x squared minus 8x plus 1. So step 1, we're going to find the axis of symmetry. And remember, we wrote that formula on the previous page, but it's here as well. So x is equal to negative b over 2a. So before I do this, I'm going to come over here on the side looking at this equation, and I'm going to write what a, b, and c represent. What number is in place of each of those? So in place of a is a 4. In place of b is negative 8. And in place of c is positive 1. Okay, now I'm going to come over here. Oops, there we go, and plug in. So negative b over 2a, well, b is negative 8, so I'm going to write it as negative 8. I'm just going to put the negative sign up in the numerator. I could have put it in the denominator. So this first negative sign came from right here, okay? And then the negative 8 is right here, okay? And then 2a, so that means 2 times a is 4. All right, so negative 8 is really just positive 8. 2 times 4 is 8, so 8 over 8, which is 1. So the axis of symmetry is going to be x equals 1. Let's highlight that. Now we want to find the vertex. So to find the vertex, you first need to know where is your axis of symmetry, right? Which we know is 1, x equals 1. So we're going to plug 1 back into the equation. So in other words, we're going to find f of 1. So everywhere there's an x, I'm going to substitute a 1. So I'm going to do 4 times 1 squared minus 8 times 1 plus 1. Well, 1 squared is 1. So, and then 8 times 1 is 8 plus 1. So that'd be 4 minus 8 plus 1. So that's negative 4 plus 1, which would be negative 3. So what's that negative 3? That is the y-coordinate of your vertex. So the x-coordinate of the vertex is 1. The y-coordinate of the vertex is negative 3. So I'm going to highlight that. Oh, and I guess I could have written some of this here. A, B, C. Okay. Now, is the parabola going to open up or down? Well, remember we said A determines whether or not the parabola opens up or down. A is positive, so it'll open up. Since it's going to open up, that means we have a minimum. And the axis of symmetry we just found is x equals 1. And we just found our vertex is at 1, -3. The y-intercept. Remember, the y-intercept is going to be the ordered pair 0, comma, whatever your c value is. Well, my c value here is 1. And then the last thing here is asking for a point. So we'll come back to that in just a minute. Let's go ahead and plot what we know. Let's start with the vertex. So my vertex is at 1, -3. So there's my vertex. And my y-intercept is 0, 1. Okay, now here's what I do next. I know it's going to be that U shape. I know it's going to be something like this, right? It's going to be sort of like that. But I need another point to balance it out. So here's what I do. Imagine this is my axis of symmetry, right? So you see the y-intercept is right here, and it's 1 unit to the left of that vertical line. So I'm going to go 1 unit to the right. Boom. There we go. There's where the other point should be. Right here. Because remember, that vertical line was your axis of symmetry. So if I fold along that line, everything should line up. So there we go. So this is my parabola would look something like that. Okay. So there we go. And so another point, let's use the point that we did that for symmetry purposes. So that would be this point right here. So that's 2, 1. Oops, I did not mean to do that. There we go, 2, 1. Okay, so now it's going to be your turn. I want you to do this problem right here. So pause the video and try this one on your own. Remember, you can look back at what I did on the previous example to help you. So pause the video and try it now. Hey guys, so here is my work for that problem. So go ahead and pause the video really quick and check over that. Okay, great. If you have questions, make sure you bring them to my attention so that I can be sure to help you. Let's go to the next page. So now we have vertex form, okay? And that's this form right here, f of x equals a times x minus h squared plus k. Now in this case, the vertex is always the point h comma k. So let's look at the first example here. It says to find the vertex and find a. So be really careful here with the signs, okay? So my vertex, it's always x minus h. So first thing I'm going to look at is this in the form of x minus h. It is. So 2 is in the place of h. And then it's plus k. Does this say plus k? It says plus 4. Okay, so 4 is in the place of k. So this one is straightforward. And a is going to be the number that's hugging the parentheses there, which in this case is 2. Specifically this 2. Okay, look at number 2. So this time this says x plus 3 in parentheses. Well, we're supposed to be minus h. Let me come over here, minus h. And that says plus 3. So it's actually going to, the h here is actually going to be a negative 3. So be careful with those signs. So I'm going to put a negative 3 right there. And then it's plus k. So this is minus 5. So that's actually going to be a negative 5. Okay, and then our a value here is the number that's hugging the parentheses. So in this case, that's that negative 4. All right, let's look at number 3 now. Slide. See if I can do that. Okay, So our vertex here, be very careful like I was saying before. So this is in the form of x minus 1, that says x minus h. So it's the same form, so we know the x coordinate or the h value is going to be a 1. So for my vertex it's a 1. And then that says minus 2, okay, but it's supposed to be plus k, but instead of it's the minus 2. So that means k is going to be negative 2. So my vertex would be at 1, negative 2. What's a? What's the coefficient, or what number is hugging the parentheses? And if you don't see a number, then the a value would be a 1. Here, think of that, there was a negative there, so treat it as a negative 1. So a is negative 1, okay? Let's try and do a graph. Let's try and graph one when it's in vertex form. So this time we've got f of x is equal to 2 times x minus 3 squared minus 4. So our a value here is 2, which means that the parabola will open up. It'll be that U shape. And then is it a maximum or a minimum? Well, if it's a U shape, then that's a minimum value. All right, we're going to skip the axis of symmetry for just a minute, and we're going to go directly to our vertex. So H is right here, and K is right here. Now, be careful. It's supposed to be X minus H. So that's my H. And my K, though, should be negative 4, right? Actually, I shouldn't have put that there. So we're going to look here for H, and we're going to look here for K. So my vertex would be 3, negative 4. Okay, now let me go back to the axis of symmetry. Well, the axis of symmetry is always x equals a number, and it goes through the vertex. So it's going to be the same as the x coordinate of my vertex, which in this case is 3. So it's going to be x equals 3. I don't have to do what I did before, that negative b over 2a. Okay, my y-intercept here, that one is going to be a little bit more challenging to figure out because the y-intercept is not going to be that negative 4. I'm going to have to kind of do a little bit of work here. I have to think about if I were to factor this out and simplify it, where would all that be? And I actually could factor this out and simplify it. So if I did that, I've got x minus 3 quantity squared. Well, we know that that's going to be x squared minus 6x plus 9, because that was one of those special ones, right? And then I'm going to bring the minus 4. Let me slide this up out of the way. All right, so that's 2x squared minus 12x plus 18 minus 4. So 2x squared minus 12x, and then the 18 minus 4 is 14. Positive 14, so plus 14. All right, so now I just put it in standard form real quick. So the C value is a 14. So my y-intercept would be 0, 14. Now, the next thing that I'm going to do is I've got to do that point. Well, I'm not really going to be able to see that as easily here. Let's go ahead and graph the vertex and the y-intercept. So my vertex is at 3, negative 4. Let's see, 3, negative 4 would be here. Now, I don't actually have enough room on this graph to do my y-intercept, which is at 0, 14. But I know that the vertex is going to be halfway between, right? Halfway between here and halfway between my y-intercept and whatever this other mirror point is going to be. So if my vertex is 3 units, it's going to be 3 units to the right, then the point would have to be 3 more units, 1, 2, 3, and it's going to have the same y coordinate of my y-intercept. So it should be 3, I'm sorry, 1, 2, 3, it should be 6, 14. Okay, so the other point should be 6, 14, but we can still sketch it. It'll look something like that. Okay, so this one isn't as easy, right, graphing in vertex form, but we're still going to try it anyway. So I want you to go ahead. Now I want you to pause the video and do this problem, and then we'll check. Okay, so now I want you to pause the video and I want you to check over the answers here. So I'll give you a minute to do that. Okay, great. So now let's go to the next page. So this time we're practice graphing in factored form. So that's the form f of x equals a times x minus p times x minus q. So p and q are the blank, also called the blank, and the axis of symmetry, it tells us, can be found by doing p plus q divided by 2. So p and q are the x-intercepts. That's also called the roots of the function, or zeros. You could also refer to them as the zeros. Okay, so let's find those x-intercepts in the axis of symmetry. So how do we do that? So this is, if you'll think back to when we were solving equations with trinomials, solving trinomial equations. Remember how we factored them and set each factor equal to 0? Okay, this is going to be the same thing here. So I'm going to look at this equation right here, and I'm going to set each piece equal to 0. So the factors are -3, x minus 1, and x plus 2. Well, so either x minus 1 is 0 or x plus 2 is 0. So if x minus 1 is 0, then that means x would be 1. If x plus 2 equals 0, then x is -2. So my x-intercepts are 1 and -2. So when y is 0, the x-intercepts are 1 and -2. What about the axis of symmetry? Well, the axis of symmetry we can find by adding p and q together and then dividing by 2. So here my p and q are 1 and -2. So I'm going to do 1 plus -2 and divide by 2. So that's going to be -1/2 is going to be my axis of symmetry, because 1 plus -2 is -1, so -1 divided by 2 is just 2. So my axis of symmetry would be x equals -1/2. Let me highlight that. All right, let's do the next one. Look at number 2. So what are p and q here? So if I set, and you can probably do this in your head, so the factors are the same. If I set x plus 3 equal to 0, then x is going to be -3. So my x-intercepts are -3, 0, -3, 0. There's really only one x-intercept, so we can mark that out. So when I do p plus q, okay, divided by 2, I'm going to do 3 plus 3. I'm sorry, -3 plus -3 divided by 2. Does that make any sense? If I do that, I get -6 divided by 2, which is just -3. The axis of symmetry is equal to x equals -3. Okay, so the axis of symmetry is the same as that x-intercept. That also is telling me that this x-intercept is meaning the parabola sits right there on the x-axis. There's exactly one x-intercept here. All right, and then this last one, number 3, my x-intercept, so I'm just going to do this part. We'll do it in our heads. So if x minus 7 is equal to 0, then x must be 7, so 7, 0. If x plus 1 is equal to 0, then x has to be -1. So my x-intercepts are 7 and -1. So I'm going to do 7 plus -1 divided by 2. So that's 6 divided by 2, which is 3. My axis of symmetry would be at x equals 3. Okay, now let's graph one. So this time we're going to graph f of x equals -2 times x minus 3 times x minus 2. So the a value here is -2, which means that the parabola would open down. It's that N-shaped. Let's skip the axis of symmetry for just a minute, and let's skip the vertex. Let's go directly to our x-intercepts. Let's do that part first. So if x minus 3 is equal to 0, then the x-intercept here would be 3, And then here it'd have to be 2. So my x-intercepts are 3 and 2, 3, 0, and 2, 0. Let's do our axis of symmetry. So I'm going to add the 3 plus 2 together. So 3 plus 2, and then divide by 2. So that's 5 over 2, or 2.5. So my axis of symmetry is x equals 2.5, which means my vertex, the x-coordinate of my vertex is 2.5. So I need to find the y-coordinate of that vertex. So I'm going to find f of 2.5. I'm going to come down here and do that. F of 2.5. So that's going to be negative 2 times 2.5 minus 3 times 2.5 minus 2. Well, 2.5 minus 3 is negative 0.5, and 2.5 minus 2 is positive 0.5. So negative 2 times negative 0.5 would be positive 1, and positive 1 times 0.5 is 0.5. So the y-coordinate there would be 0.5. So let's skip the y-intercept for a minute. We're going to do our vertex and our x-intercept. So our vertex is at 2.5, comma 0.5, which would be about here. My x-intercepts are at 3 and 2. Okay, and we're not going to worry about our y-intercept here because this would be enough for right now to graph it. So I'm going to let you skip over the y-intercept and the point here. All right, now I want you to do this one. And when you do this one, you can skip your y-intercept and you can skip your point there also. So pause the video and do this problem now. Hey guys, so now I want you to check over your answer to this problem where you had to graph the function that was in factored form. So pause the video and do that now. Great. All right, so if you have questions about anything that I have done in this video, please make sure you bring them to my attention so that I can be sure to help you. Once you've turned this in, then go ahead and work on your independent practice. Good luck.